All right, so looking at number 4 from the growth and decay worksheet. The student studying foreign language has 50 verbs to memorize. The rate at which the student can memorize these verbs is proportional to the number of verbs remaining. Okay, the rate at which the student can memorize verbs. So let's say dy dt, that's the rate, is proportional to, means equals k times the number of verbs remaining. Which they tell us is 50 minus y. Well, that makes sense. If you're trying to, if y is how many you've memorized, then 50 minus y is how many you got left. Assume that initially no verbs have been memorized. So when time is 0, you got no verbs memorized. Assume that initially no verbs have been memorized, and that 20 verbs are memorized in the first 30 minutes. So after 30 minutes, we know 20 verbs. How many verbs will the student memorize in 2 hours? Oh, we got this hour-minute thing going on again. So 2 hours would be 120 minutes. How many verbs? And then after how many hours, where will the student only have 1 verb left? Oh, that's worded kind of weird. So what will be my y value when there's 1 verb left to memorize? 49. So don't put 1 there. Although if you did 1, you'd get, probably like 1 minute or 2 minutes, and then you'd realize, wait a minute, something's not right. So let's find an equation, and they all kind of follow the same pattern. Like Nick, you were pointing out, like once find the equation, and then you can answer whatever questions there are with your algebra skills. So the equation, dy over 50 minus y equals k dt. So that's the separate the variables part of the problem. Integrate. Right-hand side's easy. Left-hand side, I'm glad we picked this one. So it looks like natural log, which was all the ones we did yesterday. But what about this one is a little bit different? There's a negative. So how do I handle that? I mean, I guess I could do the u substitution. And so really I just need a negative sign in there. So negative natural log of 50 minus y. And here's another one where the absolute value bars aren't necessary because y is never going to be more than 50. You're trying to memorize 50 verbs. So 50 minus y is always going to be positive. Let's see. Before I do the fishhook thing, I probably want to move the negative to the other side. And then I can call that a plus c, or I can call it a minus c. It doesn't really matter. I'm going to keep it plus c, although now it's a different c. But we don't know what c is yet anyway. So e to the negative kt plus c equals 50 minus y. I'm going to do a couple of algebra tricks at once here. I'm going to move the y over. I'm going to move the e stuff over. So I'll have y equals 50 minus. And then I'm going to do that c trick where that c becomes a constant, although it's a different constant now. So now I've got y solved for. Now I can use the two knowns, data points, to figure out whatever I need to figure out. 0 equals 50 minus C2 e to the k times 0. E to the 0 is 1. So C2 has to be 50. So y equals 50 minus 50 e to the negative kt. That makes sense, yeah, because if t is 0, then we get 50 minus 50 is 0. So when time is 0, we still have 50 verbs left to memorize. Let's use the next piece of information, and then we can figure out what k is. So 20 verbs left after 30 minutes. Well, careful, not 20 left. We've memorized 20 after 30 minutes. Let's see, so subtract 50, divide by negative 50, is that too many steps? That would end up with 3/5 equals e to the negative 30k. Right, negative 30 divided by negative 50. Natural log both sides. And so k is natural log of 3/5 over negative 30. And so now our problem is solved. Like, we haven't answered all the questions yet, but we've solved the problem. And we would probably put k in the calculator so when we need it later. Natural log of 3/5 divided by negative 30. So there's k. But I'll just keep that in the calculator. Unless it asks for it, and sometimes it does. Yeah, number 6 asks for k. All right, all that, and now we're ready to answer a question about this problem. For A, how many verbs will the student memorize in 2 hours? So if t is 120, now it's just to plug it in the calculator problem. Minus 50 e to the negative 120k. 43.5. We had this discussion yesterday about, you can't really memorize half a word. But for the AP test, you can just put 43.52. It's fine. Like, everybody knows that you can't memorize half a word, but it's okay if that's your answer. So we've got 43.52 verbs memorized. Read the questions carefully, because on a problem like that, it might say to the nearest verb, to the nearest whole number. That way you kind of avoid that problem. Part B, after how many hours will the student have only one verb left to memorize? That means we've memorized 49. That's kind of a tricky way to ask that question. And we're trying to solve for t now. How long will it take to memorize, to get to that 49th verb? Let's see, subtract 50, divide by negative 50. So 1/50th equals e to the negative kt. Natural log both sides. So t equals natural log of 1/50th over negative k. Natural log of 1/50th divided by negative k. 229.7.
No, it's 3.5 hours.
Yeah, that sounds terrible. But this is a model, and if we graph this, there's an exponent thing going on. So I want to look at this. 50 minus e to the negative k. I can still use k. And we want to go from 0 to, we think, 250 or so. And our y value should go from 0 to 50. So here's where that last one was so, or why our number was so big, 229 minutes. It's because there's an asymptote up there. And so if it asked you to find how long it would take to memorize all 50, you would never get there because there's an asymptote. So it's a model, doesn't work perfectly. Hopefully, by the time there's only 1 or 2 left, you throw the model away and you'd be okay. But that explains why it's like, why does it really take me 4 hours to memorize that many? No, but that's where the math model breaks down a little bit at the ends. Question.
So we don't have to do the problem, but could we do the proportional to the square root of the